Hello everyone, welcome to Engineering Bookshops. For this video, we're going to solve problems on our Engineering Mechanics Statics about Chapter 2, Couple, Scalar, and Vector Calculation. So I'm going to solve problems 2.68 to 2.69. So just keep on watching guys and let's start. Okay guys, so let's start to solve problem 2.68. So for problem 2.68, we need to find the couple equivalent at A. So first, let us define what couple is. So couple, it is two parallel non-collinear forces that are equal in magnitude and opposite in direction. So for our figure A, so again guys, you must have the copy of your textbook so that you will know what figure we are solving. So for our figure A, so I will assume here clockwise positive. So again guys, clockwise positive, counterclockwise positive, it will always depend on your assumption. So you can use either of the two. So me, sometimes I use counterclockwise positive, sometimes I use counterclockwise positive, depending on the given figure. So when I see that the force will going to rotate in clockwise direction, so I will assume clockwise positive. So when I see that the force will going to rotate in counterclockwise direction, so I am assuming that it is in counterclockwise positive. But it will always be your choices which do you prefer. But me, so looking at the given figure, I see that the force will going to rotate in clockwise direction, so I will assume clockwise positive. So 10 multiplied by its moment arm, its perpendicular distance, 0.6 is 6 Newton meter in counterclockwise clockwise direction. So let's compare it to our figure B up to figure I. So for our figure B, so as I can see, we have a couple given which is rotating in clockwise direction 6 Newton meter. So therefore, B is equivalent to our couple A. So how about for our figure C? As I can see, our force is rotating in clockwise direction. So it is 15 multiplied by its perpendicular distance 0.4. It is equal in 6 Newton meter in clockwise direction. So therefore, C is also equivalent to couple A. So for D, as we observe, we have a given couple which is 6 Newton meter rotating in clockwise direction. So therefore, D is equivalent to couple A. So for our E, so we have couple 9 rotating in counterclockwise, and since I am assuming clockwise positive, so counterclockwise 9 Newton meter will be negative, and we have a clockwise 3 Newton meter, so it is positive, so plus 3. So the answer will be negative 6 Newton meter in clockwise direction. So therefore, it is not equivalent since our answer here is negative. So therefore, this one is rotating in counterclockwise direction. So for F, we have 7.5 force rotating in clockwise direction. So it will be 7.5 multiplied by its perpendicular 0.4. And another force, 5 Newton, rotating in clockwise direction. So it will be plus 5 multiplied by its perpendicular distance, 0.6 meter. And it will give me 6 Newton meter rotating in clockwise direction. So therefore, F is equivalent to couple A. So for G, for figure G, so we have force 22.5 Newton rotating in clockwise direction. So 22.5 multiplied by its perpendicular distance 0.4, and we have 5, so it is rotating in counterclockwise direction, so therefore it will be negative. So negative 5 multiplied by its perpendicular 0.6, so we have positive 6 Newton meter rotating in clockwise direction. So therefore our G is equivalent to our couple A. So for H, we have given couple 5 Newton meter rotating in clockwise direction, so it will be positive. And then we have 5 Newton force rotating in counterclockwise direction, so therefore it will be negative. So negative 5 multiplied by 0.3 plus positive 5 Newton meter, it will be 3.5 Newton meter rotating in clockwise direction. But it is not equivalent to our couple A. So for our I, we have couple rotating in clockwise direction. We have 4 Newton meter and 6 Newton meter. And we have couple rotating in counterclockwise, 3 Newton meter and another 3 Newton meter. So it will be negative. So the answer will be 4 Newton meter rotating in clockwise direction. So I is not equivalent to our couple A. So I hope guys you have the copy of the textbook so that you know why it became like this. Okay, so let's try to solve for our problem 2.69. So for problem 2.69, we have to find for our couple equivalent at A. So based on our given figure at A, we have this 3D figure. And since this one is in 3D figure, so we have to find for our couple X, Y, and Z. So for our couple X, we have to look at its front view. So looking at its front view, we have this 60 Newton, 4 meter, and 3 meter. So based on this figure, do you think we have the value for our couple at X? So again, let us define what couple is. So couple, it is a two parallel non-collinear forces that are equal in magnitude and opposite in direction. So based on this figure, do you think guys, this one is a non-collinear force? So let us define what is non-collinear force. Non-collinear force, it is a force whose line of action does not lie on the same line. So based on this figure, is this force does not lie on the same line? So as we can see, these forces lie on the same line. So therefore, this is not non-collinear force. So therefore, for our couple at X, it is equal to 0. So additional information. So if this is not non-collinear forces, what do we call for this one? So we call this as a collinear forces. So a collinear force, it is a forces which have a common line of action, or the line of action of the forces lie along a single straight line. So since this forces is lying along a single straight line, we call this one as a collinear forces. So as per definition of our couple, we need a non-collinear forces. So since this one is a non-collinear, this one is a collinear forces. So our couple at X will be 0. For our couple of Y, so how are we going to find for our couple Y? So we are going to look at its right side view. So looking at its right side view, so we can see our forces is along here. So therefore, we cannot see at right side view for our forces. So therefore, for our CY, it is equal to 0. And now, let's find for our couple at Z. So for our couple at Z, we are going to look at its top view. So this is our 60 Newton. This is 5 meter. And this is 4 meter. So based on this figure, do you think we have the value for our couple at X, couple at Z? So as you can see, this forces is a non-collinear forces. Since as we define non-collinear forces, it is a force that does not lie on the same line. So since this one is a non-collinear forces, we have the value for our ZY, CZ, for our couple at Z. So I am going to assume clockwise positive. So we have 60 multiplied by its perpendicular distance 5. So we have this 300 Newton meter in clockwise direction. So if it is required that you must have to give the direction of our couple, so this one will be in negative 300 Newton meter. Why? Because based on right hand rule, clockwise means negative. So for our couple at A, we have negative 300 Newton meter. So we don't have the value for our Y and X, but we have the value for our Z. So we have a total couple equivalent at A, a couple at A equals to negative 300 Newton meter. And now let's try to compare figure A to our figure B. So same explanation at A. So for our couple X, so looking at its front view, so as we can see, this 75 Newton cannot be seen but lying at point here. So for our couple X, it is equal to 0. For our couple Y, so looking at its right side view, so we can see these forces, and as we can see, these forces is lying on the same line, and we call this one as a collinear forces. So therefore, our couple at y equals to 0. And for our z-axis, looking at its top view, we have the 75 Newton, 5 meter, and 4 meter. So since this one does not lie on the same line, we call this as a non-collinear forces. So therefore, we have value for our couple at z. So taking moment, so I will assume clockwise positive. So 75 multiplied by its perpendicular distance 4. So we have couple at z equals to 300k Newton meter in clockwise direction. So if we need to put if it is negative or positive, so based on our right hand rule, if it is clockwise, then this will be in negative direction. So it will be negative 300k Newton meter. So for our couple, we have cy equals 0, cx equals to 0. So our total couple will be c equals to negative 300k Newton meter. And as we can see, it is equivalent to our couple at A. So for the continuation of our problem 2.69, so this is the given figure for our C. So this is different on how we solve figure A and B. So we are going to use vector calculation for this one, and we need this following formula. So couple is equals to C multiplied by its unit vector, where C is equals to force times R. So what is our force? Our force is 75 kilonewton. And what is our R? So our R will be the distance from this one to this one. So I connect the tail to its head. So you can also connect from here to here as long as you are connecting this tail to the direction of these forces. Okay? So for this one, as you can see, this is the right triangle, and it is different to the right triangle from this one. So for me, I am using this one. So we have rectangular here and diamond here. So for looking at this right triangle, we have distance 4 meter and 3 meter, and of course the hypotenuse is 5 meter. So alternate 4, 3, 4, 3. So therefore, I can know the distance here. So looking at this one, so this will be 3 and this will be 4. So applying at the formula, so we have force 75, we have R, so our R will be the distance here, which is 5, and our Y, which is J, is this one. So what is the distance of that one? This will be, so it will be 3, so it will be negative TJ because it is going on its negative direction. And then this one is 4, negative 4, since this one is going to the negative Z direction. So this distance is 4 over square root of 3 squared plus 4 squared equals to 5. So applying your calculator, so 75 multiplied by 5 multiplied by negative 3 over 5. So we have negative 225 for our J or Y axis. And then for our Z axis, is this one is 4. It is negative 300k Newton meter. And now for our figure D. So same explanation for our A and B. So for our couple at X, so looking at its front view, we have these forces 100 Newton, 3 meter, and 4 meter. And since this one is a non-collinear forces, since our force do not lie on the same line, so we have the value for our couple X. So it will be assuming clockwise, counterclockwise positive, so it will be 100 multiplied by its perpendicular distance 3 I Newton meter. So since it is in counterclockwise direction, so based on right hand rule, counterclockwise is positive. So for our Y axis, so looking at its right side view, as we can see, this is where our force here, and we cannot see our force like this. So our couple Y equals to 0. So looking at its top view, so as we can see, our forces is lying on a same line. So therefore, for our ZZ, for our couple Z, it is equals to 0. So summation of our couple, it will be C is equals to 300I Newton meter. So therefore, this is not equivalent to our couple A since our couple A is equal to negative 300k Newton meter. So for our E, so I do not include the figure. So again guys, you must have the copy of the textbook for this one. So for E, so looking at its front view, so let us solve first 45 Newton first. So looking at its front view, we have 0 for our couple X. Looking at its right side view, we have the 45 Newton in non-collinear forces. So therefore, we have the couple for our Y. So I will assume counterclockwise positive. So rotating, so 45 Newton is rotating in counterclockwise. So it will be 45 multiplied by its perpendicular distance 5. So it will give me 225 Newton meter in counterclockwise direction. So based on right hand rule, counterclockwise is positive. So this will be positive 225 J Newton meter. And for our Z, so looking at its top view, so we cannot see our forces. So therefore, our couple Z is equal to 0. And now, let's try for our 475 Newton force. So for 75 Newton force, so as you can notice, it is the same on our figure C. So I will not going to show you the solution for that. So just look for our figure C. So it is just the same for that one. So we have couple equals to negative 225J minus 300K Newton meter. And now we are going to add this couple so that we can solve for our couple. So for Cx we have 0. For Cy we have 0 also since 225 minus 225 equals to 0. And we have negative 300K Newton meter. So here we have the value of couple equals negative 300K Newton meter. And this one is equivalent to our couple at A. So for our F, so this is our given figure. So let's try to analyze 45 Newton first. So for 45, looking at its top view, we have a non-collinear force. So 45, assuming counterclockwise positive, so 45 multiplied by its perpendicular distance 4, it will be 180 I Newton meter. So since this is in counterclockwise direction, so therefore, based on right hand rule, counterclockwise is positive. So we have couple at x equal to 180 I Newton meter. So for our couple y, if we try to look at its right side view, it will lie on the same line. So therefore, our couple y equals to 0. And for our couple x, z, looking at its top view, as we can see, we cannot see these forces. So couple at z equals to 0. So for 50 Newton force, so as we can see, this forces is something like this. So we are going to solve it using vector calculation. So this is the formula that we will be needed. So applying this formula, we have force 50 Newton. Our R is the square root of 34. So how that happens? So looking at this one, so I connect this tail to the direction of this force. So this will be the value of our R. So it is square root of 5 squared plus 3 squared equals to square root of 34. And for the distance of our J and for our X and Z axis will be negative 3 J minus 5K. So how does it happen? So looking at its right side view, so this is our right triangle. So this is 5 meters and this is 3 meters. So we need the distance at this right triangle. So looking at here, so this is 5, this is 3. So here, this one will be 3 and 5. So for our x-axis, so since it is going toward the negative x direction, so this will be negative 3j. And for our z-axis, so our z-axis is 5. So going to the negative c direction, so this will be negative 5k over square root of 3 squared plus 5 squared equals to square root of 34. And using our calculator for this one, okay, so for let's calculate. So 50 times 3. So actually, we can cancel this square root of 34. So 50 times 3 is negative 150. 50 times negative 5 is negative 250. So I think there's no need to calculate for that one. So the answer for our 50 Newton couple will be negative 150I minus 250K Newton M. And we're not yet done here, so we are going to add all for our 45 and 50. So for our X, we have 180 minus 150, which is 30I. And we have negative 250K Newton meter. So as we can see, this one is not equivalent to our figure A. So overall, based on our figure B to F, so only figure B and E is equivalent to our figure A. So this is our problem 2.69.